let's focus here. So we will use two functions, Normalcdf and inverse norm. Those are very important. We use these when the values do not appear on the graph. Okay, that's when we use those. I could also say we use them when there's no graph provided. Okay, no graph required or provided. That's another key for you using your calculator. Okay, so how would we access Normalcdf and inverse norm, you might ask? Well, it's actually fairly easy. I'm going to clear my screen here. You just go second vars, second variables. Vars is right here under the arrows here, next to clear. So you go second vars. You got to make sure you don't pick PDF. It's Normalcdf and inverse norm. Those are the only two that I'm going to be using in this course. Okay. Second vars, boom, there it is. So let's see what they do. Okay. Normalcdf requires 4 entries, guys. Lower limit, upper limit, mean, standard deviation. Every single one of them needs the mean and the standard deviation at the end. Watch this, the bottom one here, mean, standard deviation. But this one requires 4 entries. 4 entries, okay? We'll calculate the probability of data points existing between two values. The answer is given as a decimal. Watch, very, very important. The answer is given as a decimal, multiplied to 100 to get the percentage. So we'll always return a decimal to you, okay? Normalcdf needs 4 entries separated by commas. Okay, they have to be separated by commas. Lower limit is the value that would be to the left side of the curve, right? Left side of the x-axis. Upper limit would be to the right side of the curve. Okay. The problem is with this one, there is sometimes no lower or no upper. And you're like, how so? Well, what if I asked you a percentage of people that are taller than 180 centimeters? It's just taller, right? 180, that's your lower. How high do we go? I'll show you how to deal with that, okay? But then you must give it 4 entries, okay? Remember, remember, I'm going to use a different highlighter for this one. Remember that if z-scores are given, this is important. I added that just for you, this group. If z-scores are given, we know that the mean is 0 and the standard deviation is 1. Don't forget that. If I give you a z-score, I do not have to tell you what the mean and the standard deviation is. We know that, right? Because the z-scores have a 0 right underneath the mean. Remember that, right? Underneath the mean, we put a 0, and then we go up by 1 to the right or down by 1 to the left. Okay? Remember this fact. Okay, so I came up with some examples to help you out here. So I will say assume, let's go example. Assume that the mean income per household is $45,000 per year, and sorry, with a standard deviation, with a standard deviation, just for space, I'm going to use SD of $15,000. Try to be conservative with your space, okay? Because I'll add at least two questions here. So what if it asks you, using technology, determine or calculate, let's go calculate the percentage of households with incomes. I'm trying to get, yeah, there we go, with incomes between $32,000 and $65,000. And you're like, should I be drawing my normal curve and coming up with the values? I didn't ask you to graph it. So from now on, if you don't graph it, use your calculator. I will actually say use technology to figure this out. And even the fact that it says calculate should tell you. Okay, so we're going to use Normalcdf to do that. No, so I want you to show me this. You can't just come up with an answer. Normalcdf, just like that. The lowest value here is 32,000. That's the low limit. The higher limit is 65,000. Our mean is 45,000. Notice that I go comma, right, between every entry. And the standard deviation is 15,000. Okay. So let's figure out what this is. Grab your calculator. I'm going to quit this. I'm going to go second vars, Normalcdf. So we go 32,000, comma, 65,000, comma, 45,000, comma, 15,000. Close the bracket. 4 entries right there. Hit enter. And we are told do not round here. That is as a decimal. We're going to go times 100 to get that as a percentage. So you just shift the decimal or just multiply it by 100 on your calculator. 71.57% of households. There's a 71.57% chance that a household makes between those two incomes. Okay, based on the mean, based on the standard deviation. Okay. B, that's the only other question that I can fit in here. Okay. Households earning less than $27,000. Question mark. What are the percentage? I should say this. Sorry, guys. Can we just make sure? Because percentage of households. So it's like chances that a house, because we don't know the exact number. I would have to give you, hey, we're considering 1 million households, right? We don't know that. So it's percentage. So we can use this later to figure out the actual number of households. So Normalcdf. How do you deal with this? A lower limit. What would you put on the low end? A really small number. That's the answer. A really small number. So watch what I'm going to do. I'm going to go negative 10,000. Isn't that overkill? Yeah, you can go negative 1 million if you want. Even more overkill. But you're really saying, hey, like, I want everything as far left as possible, all the way up to 27,000. But you need to have a lower limit, okay? Very small numbers. So just pick very small number, okay, for this one. So we're saying anywhere from negative 10,000 all the way to 27,000, and then you have to follow up with the mean and the standard deviation. Let's go ahead and figure out what that is. You can copy paste, or you can just go second vars. It's quick to go get it. And then so we get 0.1149, and that keeps going times 100. That's 11.49%, okay, of households. Right, earn less than 27 grand. So that's how we use normal CDF. So normally you would say, hey, where's this number on my normal curve? It's right here. I'm going to add percentages either to the left or to the right, depending on the question. Normal CDF does that for you. Exactly, okay? It finds it exactly. Very precise, okay? So that's how we deal with. So hold on, guys. I don't have space, but what if it says percentage of households earning more than 27,000? Then you would have to put, you're watching, right? 27,000 right here. And then over here, you can put a million or whatever, some big number. Because let me just show you, if I were to reduce this first number to just, let's say, negative 1,000, I'm going to delete a 0 and hit enter. It's a little different, right? It's a little different. Your answer is slightly different. So just go as small as possible, okay? And you'll be fine. I wouldn't take marks off. If you showed me this entry and yours is a little different than mine, I would not take any marks off. Sure, I would accept that too. You know how the curve never touches the x-axis, so that's why I just go as far as possible to include everything that could possibly be there. But yeah, negative 10 would be fine because it is less than 0, right? Who makes less than 0 a year, right? So that'd be fair to say. So I will just say this, pick very small number. I think this is worth mentioning. Inverse norm, the other guy, the other function, okay? Inverse norm. What does it, how many entries are there? Percentage of data below mean standard deviation. Let's just write that down. 3 entries. Only 3 entries for this one. I'm going to highlight that. Only needs 3. And another thing that I forgot to mention, and it's very important, this has to be as a decimal. It's going to be so busy there. I don't like it that busy, that crowded. Next year. Come back next year. Redo grade 11. No, don't do that. But that would be as a decimal, right? This has to be stated as a decimal percentage below. What will it do? Watch this. We'll calculate the actual value along the x-axis we're looking for. So it doesn't give you a percentage, guys. It gives you the actual value you'd be looking for. It could be height, weight, number of days, you name it. And here's where I need you to pay attention. If 35% of people earn more than $50,000 a year, if the question says that, earn more tells you that the 35% would be above or to the right of the 50,000, right? Would you agree with that? So that means that you know that the entire curve is always 100%. Always remember that. It's so critical. It's trivial, right? If the whole curve is 100% and this is 35, right? You're saying that if you had a $50,000 a year income, that means that 35% of people make more, and therefore how many make less? What would you say? 100 minus the 35, okay? And that puts you at 65%. And this is the value we're after. This is the percentage. You always want to find the percentage to the left of the curve. So I also need you to know that this would be earning more, and if you were to go to the left, you'd be earning less, right? More, less in this case. So this is the value we need for inverse norm. 0.65 goes into inverse norm. Okay. How about I give you something like this? If 42% of students spend less than 15 minutes on homework, then, right, where would you put the mark along the x-axis for the 15 minutes? Listen carefully. If the question said that 50 spend less time, 50 spend more, right? You would know that. That would be right down the middle. But you know that you have to make the mark somewhere here. Why is that, Mr. Dirksen? Why did you put it to the left? Because I have 42% spending less than 15 minutes. Therefore, how many would be spending, what percentage would be spending more than this value here? You go 100 minus 42, and that is 58, right? Would be spending more time, 42 spend less time. But Mr. Dirksen, why did you do the 58? Because we don't really need it, right? This is the one, you already have the one that inverse norm would want. Okay, this is what we need this. So sometimes it's given, sometimes you have to, they'll give you everything to the right, so you have to find the percentage to the left. Let's do an example here. Example. I'm going off of the very first one we did, okay, the household income. This income would have 30% of households earning less. And I know it's going to be a little tricky, but they're asking this income, not percentage, not like what's the probability. This income would have 30% of the household earning less. Let's do a little bell curve, okay? Let's just do this on the side here before we go ahead and use inverse norm. This income would have 30% of the household earning less. If it said 50, you'd be right down here. So 50 would be less, 50 more. You have to come somewhere over here, because if 30% earn less, right, this is the question mark. We want to know what income would we have to have so that 30% earn less, 70% earn more. Okay, so let the percentage help you to determine where along the x-axis you should be located. So we go like this. Inverse norm Don't put 30%. That's a common mistake. Your calculator will say error, can't do it, right? So we go 0.30, right? Just to make that point very clear, right? 30% turned into 0.30, and my mean is 45,000, 15,000. We're still continuing from that household example up there. Let's use our calculators for this. And again, practice is what you need. There's no other way around this. Second vars, inverse norm. We go 0.3, comma, 45,000, comma, 15,000, close brackets, 3 entries only. And there it is. That is the income that would make that happen. Okay? The answer is, and we're in dollars here, right? 37,133.99, right? That is the income that you would need. One last example. What income would place you in the top 20%? What income would place you in the top 20%? First of all, you should realize no normal CDF here because they're not asking for percentage. We're actually given the percentage, so it's inverse norm time, all right? But if you see something like this, this is saying, hey, what income to put you in the top 20? You would have to see that we're talking that the 20% is way at the top here, making a lot, right? So this is the value we're after, and we're told that that would put you in the top 20, right? Somewhere in here. At the minute you make this much, you are at the top 20%. If you earn more than that, you'd still be in the top 20, but this is like the cutoff. So if this is 20%, then this is 80. Thank you. Right? Right? That's 80 because 100. So inverse norm, 45,000, 15,000. I want to finish this and send you off. I do want to give you some homework. Sorry, because we're a bit tight. So 0.8. I'm just going to copy the top one here. 0.8. Enter. 57,624.32. There we go. Oof, the bell is going to go right away. Here it is. Here it is. I want you to try 33 to 35. Write this down. 33 to 35. And here's the deal. Okay, I am very sure I have a video on how I do that one. 33 to 35. So if you're stuck, look it up. Okay, I'll post the stamp key and the video if you want. But please give it a try. Okay, give it a try. It's basically one long question. Have a good weekend, guys.